Hello guys, welcome to another video. This one we're gonna do a quick comparison between traditional modeling and procedural modeling, just to compare the pros and cons, and then talk about like the different mindset when you're doing procedural modeling or traditional ones. Um, and in recent years, especially, procedural modeling are becoming more and more popular just because it's able to produce like massive things in whatever kind of like context, like sci-fi or natural environment, or even just for production pipelines to, quickly generating very varying assets, making hairs for characters, rigging, right? All those things. Procedural workflow becomes more and more popular just because its productivity is going to be skyrocketing compared to traditional ways. And it is also not something new. It's been there for the longest time. Houdini is 1 year older than Maya. Um, and those two software has been there for the longest time, and Houdini is nothing new in the industry. It has a very long history. It's been the king of VFX for ages, right? So this is nothing new, but in recent years though, it just becomes more exposed, and more artists are trying to kind of like take advantage of this procedural way of making stuff. And I think that's kind of like important also to mention it so that that there's this new kind of like trend of trying to be more procedural. And also in recent years, not just for modeling, but texturing wise, we use Substance Designer a whole lot to make textures instead of like dragging things from Google search or whatever. So procedural is is kind of like becoming more and more important. And if nothing more, right, learning Houdini will be the one of the best strategy to find a job. If you want to find a job as like a character artist, it's gonna be super difficult. But if you can do Houdini procedural modeling or VFX or whatever, there is a high demand for that. So if there's nothing more, I think expose Houdini to the students will be a good strategy. Just because it's actually pretty in like high demand. Anyway, so just a brief look on how does it feels like to do modeling in Houdini compared to a traditional software. Okay, so we're going to build something fairly simple. We're going to build something like a stair. Okay, so traditionally we'll do a stair by starting with kind of like a box, right? And then you make it somewhat like a stair shape. So we could just scale it up. Okay, maybe we can flatten it on the Y direction just to make it more flattened. And then we can maybe add a few more edge loops to this. So a few more edge loops in here, right? And then we could maybe we can make this longer on the X direction, I guess, right? Okay, and we can add a few more edge loops here. Okay, yeah, and then we could just go ahead and maybe just get. I think it will be easier to start with actually the face. Anyway, yeah, we can then go ahead and go to maybe the front view, right? We can then grab some faces and basically deleting them, right? I also go to face mode and grab all the faces. That's irrelevant. All these guys. Okay, and leaving us just a stair shape basically, right? That's how we kind of like do this more or less. There would be maybe there are other like alternative ways to do this, but that's the general trend, right? And delete all the faces, oh, including you also. Anyway, and you just basically, oh, I think I deleted something there I don't want it to. Maybe I was selecting it in the wrong way. All right, deselect that and that and that and that. Yeah, that's actually pretty good. Pretty good now. So I'm gonna go delete all the faces. Probably better to just re-extrude out everything there actually. So, right, I'm gonna grab all the faces and then extrude. Okay, now we got a stair, right? That's basically how we do things here, like in the traditional package, right? We just have some basic modeling, adding new faces, extruding out, deleting faces kind of thing, manipulate the topology and do whatever, right, to get it done, right? So yeah, that's basically how we do this traditionally. But there's basically no problem in this workflow, but when you wanted to create more stairs, like you're creating like a building with a whole lot of stairs, and those stairs maybe are having kind of like different height. Maybe some of the areas are having more stairs. Maybe they need different height, right? Maybe they are having different handrails or whatever, right? And then it becomes a problem because you have to then remake stairs again and again or make adjustment all the time to be able to use it, right, in various places. Okay. Well, in Houdini, that could be something that's not a problem because in procedural workflow, you can actually set up a system, a rule, so kind of like build it stair based on a bunch of parameters. And then if you want to have more stairs or different height for the stairs, you can do that by changing a few parameters down the way. Okay, so yeah, let's take a look at that. I'm gonna go create a geometry here, right, and go inside of it. And then we can start with something. There are many ways to do this, but I'm gonna start with some a little bit more technical ways, just because I learned it this way. So I'm gonna add a point here on the origin, right? So there's kind of like a point in there. You can take a look at that point. You can see it's in there, right? And it has a number of 0. Okay, and then I'm gonna go create another attribute wrangle here. This is gonna be a way to use expression to define like how things will be done, right? So in the details panel, which is in the in the run over details, I'm gonna try to set up some rules to add a few more points, right? So we kind of wanted to go for this up in order to add more stairs, right? Every time we need to have like a new stair, we go creating new points. Okay, so 1, 2, 3, and then up in. So every time we just need to have 1 point going up, 1 point goes in, and that's one more stair, right? So we need to know how many stairs do we want to have. So we can say int channel int stairs, actually stair count maybe, will be equals to a channel of a integer type stair count. Okay. Bear in mind that this thing I'm showing you now may not be the easiest solution, but it's going to be the most resembling like a technical way of doing this. We're adding like we're now getting a channel called stair count in here that's invoked by this code, which created this slider and gives you the an integer number basically, and you got that number, and it's going to build that much stairs. Okay. And meanwhile, we also need to know like the stair height will be equals to another channel of the float type. So if you don't specify a type, it's going to be default to float. You can say stair height, right? That's a height of one stair, and then stair depths, right? And this is also more architecturally manageable, right? So this is going to be the right. Otherwise, if you're building like a realistic stair, you have to really do your calculations, do your math, and make sure this is the correct size. Otherwise, you know, it's not gonna work. But here we're already doing it like technically, like specify the actual correct dimensions. So stair depths. Okay. All right. So we have all these things now, and that's gonna be our basic information. And we just need to go through a for loop for int stair count. Actually, that's already used. So integer stair should be fine for counter. Equals to 0, right? We then say stair counter will be smaller than the stair count, and then we increment our stair counter. Right, and go through a for loop. Okay, and then we can start adding our points. For every loop, we add 1 point above and 1 point in, right? So going above is kind of like simple. Oh, and now we can also remember the previous point location, right? So In the beginning, of course, the previous point location will be the nothing. So vector previous point location will be equals to a value of 0, 0, 0 on the origin, because that's basically where this point is, right? So, and then for every time we go up, we need to add something, right, and increment the previous point location. Okay, so the new location for the first point, we can say vector. Every time we create 2 points, it will be easier to say point 1 will be equals point 1 position will be equals to the previous point location plus a vector that is going up of the stair height. So 0 and then stair height. Actually, that has to be passed through a function if you're using variables. Right, we're going up, right? This new position will be basically here, somewhere higher than the previous points, right? And then vector point 2 position will be point 1's position going deeper. That position will be equals to point 1 position will go deeper inside. It could be go this way, could be going this way or that way. I think positive is actually this way, so that's good. Let's say set, and then we're gonna go for stair depth, and then we go for 0 and 0, and then we just set the previous point location to be now the second point location. That way we can always update it, right? Point 2 position. Right, so next time when we go through this loop, it's gonna go from here now, from the new point. Okay. Of course, we're just getting locations, so we need to actually add points, right? So we're gonna say add point, right? And we add point to our geometry, which is 0, the first input, and then add its location. For the first point, and we add another point, and you guessed it, point 2 position. Right, this is kind of like technical. I can run this, and then we can go click on this slider, so we can define the height and the depths. But you can see how we're able to really define how many stairs do we want, right? How high they are, and how deep they are, right? Oops. But there's one more problem, right? This is not a stair, right? This is just a bunch of points, and we need to eventually go down here to add another point, right? So final point will be the previous point location. I can say vector final point location will be the previous point location. Okay, but just make it y-axis to be 0 basically. So it's gonna be set previous point location dot x 0, and then previous point location dot z, right? And then we add our last point, so that we can fill this into like a plane, right? So we're adding points, and it will be also to our geometry and final point location. Around this, you can see we're adding one more points. Now, because we're adding this in the correct order, in the next node, we can just go create a node called add node. Okay. Now this add node will be able to go to polygons and go by group, and then you can close. Now we're able to build this stair, right? Cool. And then we can go ahead and say, okay, I wanted to make the stair to have more stairs. I can go do that. I can have like higher height, or longer depths. You can see this is gonna be way more flexible than what's going on here, right? You can specify the exact numbers. You can specify how many stairs you count, especially this stair count, right? This is gonna be like, if you want to add stair count here, how do you do that? Well, you have to extrude from here and keep on adding. Maybe there's a different ways, like maybe there's like a procedural way of doing procedural stuff, like operations kind of thing. But again, you can see how flexible you can do with like vex coding, right, in Houdini, to do exactly what you want, nothing more, nothing less, right? That's gonna be more performant, more flexible, and more reliable because you define it yourself. If there's something wrong, right, you can look at the rule exactly. This is like the source code, right, of what's going on. All right, pretty cool. So yeah, all the left is basically adding the thickness. We can say we can add a transform node here, and we can transform it on the z-axis, right? And then we can do an extrude, poly extrude to extrude out. Oh, actually, there's one thing I just learned from my colleague. GIM extrude or something like that. GIM thicken, right? GIM depth thicken. And I can go there, and you can change the depths. Okay, and that's gonna do both directions. Yeah, that way you don't have to do the the moving and extruding. You just got this thing expanded out to 2 sides, which is pretty cool. All right, cool. So now you can see we're able to build a stair that's much more flexible, right? We can now create controllers, right? We can then we can actually grab all these things together, and we can go to asset and then new digital asset, and we can call this guy stair generator, right? We can go ahead and accept that, and it's going to ask for a few parameters you can give it. So we can go inside of it and say, okay, I need all of these things I have here, just drag them over to the parameters, and maybe the depths here. I can rename those parameters to be stair. This is not stair width, right? Okay, so we have height, depth, and width, and count. Apply and accept. All right, so now you can see we can grab this, go back out and grab this thing. We can change the stair count, stair height. It's all now encapsulated into this, almost like a class, right? You can do whatever you want to this thing. Okay, now this is not a complicated example for sure, but you can already feel the power of procedurally building your asset instead of just having a dead model that's not being able to do variations. Okay, but I think there are still like a lot of places you want to build everything artistically from scratch, especially for characters, right? I don't think there is any way to build a character procedurally completely from scratch. That would be too difficult of a rule to implement. But nonetheless, for like, you know, simple things like this or something even more complicated, you're able to build it procedurally, and you're able to make variations when, you know, in various different aspects of this model. All right, so that's going to be a quick preview on the comparative differences between traditional modeling and procedural modeling. Okay, thanks for watching. See you next time.